Well, good morning. Today we're talking about the Pythagorean theorem. The Pythagorean theorem is usually stated as a squared plus b squared equals c squared, but those just represent sides of a right triangle, and they could actually be represented with any letters. So here we have a triangle with the legs are labeled as F and G. And these are the legs because they're the two pieces of the triangle that make the right angle. This little square box means that's a right angle, which means 90 degrees. And the side across from the right angle is the hypotenuse. And we have it labeled as H for hypotenuse in this case. It's also the longest side of the triangle. And if you take the longest side of the triangle and square it, you get the same thing as if you squared the other two sides and added those together. So we have h squared equals f squared plus g squared. I don't know if you can see that f squared. It looks kind of faint with but maybe I should do it darker. Let's do it in a darker green. But you have this on your paper as well. This is side F of the triangle. So F squared plus G squared equals H squared. Now, let me show you how this works. So if we took those sides of the triangle and we said that the side F was 3 long and we made a square off of it. So this side is 3 and this side is 3, then the number of units in that square are 9. 3 times 3 is 9, 3 by 3. So that's why we're squaring that side, because we're making a square there. And let's say this G side is 4 long. And so you see there's 4 boxes there and 4 boxes here. 4 times 4 is 16. So there's 16 small boxes inside this. So 4 squared is 16 and 3 squared is 9. And let's say the long side, the hypotenuse, is 5. And so we make a square off of that side as well. And 5 by 5 is 25. So now you can see that if you add all the little small squares up in these two, 9 plus 16 equals 25, which is how many squares there are in that. And that will always work with a right triangle. So as long as there's a right angle in the triangle, if you square all of the sides and you add together the two shorter legs that make up the right angle, you'll get the same thing as the other side squared. So that's what the Pythagorean theorem says. Now, let's put this into action. Let's apply it. So the next page in your packet, you have this. We have a triangle here, a right triangle. They haven't marked the right angle, but you can see that this is the 90-degree angle here. So the 15 and the 13 make up the legs. These are the two pieces that make that right angle. So we're going to square those each and add them together. 15 squared plus 13 squared will equal the hypotenuse, the long side squared. And 15 squared is 225. You see that down here. And 13 squared is 169. You see that here. And if you add 225 and 169, you get 394, Well, that is the length of this side squared. So how do we find out what the length of that side is? Well, how do you undo squared? You take the square root. So the square root of 395 is about 19.85. So the hypotenuse of this triangle would be 19.85. And you see that it's a bigger number than both 15 and 13. It's the longest side of the triangle. Now, if you have a triangle that looks like it might be a right triangle, and you want to check, you can say, it looks like maybe this is a right angle. So let's check and see if the Pythagorean theorem works here. So let's take the 16 and square it, and the 14 and square it. So I'm just going to do this down here. So 16 squared plus 14 squared. And we'll see question mark, does that equal 22 squared? Okay, so 16 squared, you might not know that off the top of your head, so you can use a calculator. Sixteen times 16 is 256. So this is 256. And what is 14 squared? Let's see, 14 squared is 196. So this is 196. And what is 22 squared? 22 times 22 is 484. Now, let's add these together. If I add 196 to 256, I get 6 plus 6 is 12. 9 plus 1 is 10 plus 5, 15. We get 452. And 452 does not equal 484. Therefore, this is not a right triangle. Because all right triangles will follow the Pythagorean theorem. If you square the two shorter sides and add those together, you will get the longer side squared. Since that didn't work here, we've shown that it is not a right triangle. All right, the next one here we have, given a right triangle with the hypotenuse is 27 and one of the legs is 17, what is the other leg? Okay, well, we know that the long one squared, so the hypotenuse is 27. 27 squared will equal 17 squared plus the unknown side, x squared. Okay, so let's see if we can figure out what that is. Well, 27 squared is 729. And 17 squared is 289. Now, we want to find out what this is, so we need to get rid of what's added to it. Since this is a positive number, we're going to have to subtract 289, and then we'll have to subtract it from the other side. So those go away, and just to make sure, 729 minus 289 is 440. So 440 equals, those canceled out, so all we have over here is x squared. So the unknown side of the triangle squared is 440. So to find out what it is, undo squared, we do square root. So we need to take the square root there. So this will give us x. And what is the square root of 440? It's about 20.98. 20.98. So the other side of the triangle that has a hypotenuse of 27 and one leg is 17, the other leg would be 20.98. Okay, now let's look at this last one here. It says find the missing side of this triangle. So we have 42 and 75. Do we have two legs there, or do we have a leg and a hypotenuse? It looks like this would be the right angle. So the side across from the right angle is always the longest side. That's the hypotenuse. So we're going to say that one is 75 squared equals 42 squared plus x squared. So we'll call this other side of the triangle x. All right, now we need to find out what those numbers are. So 75 squared is 5,625. 5,625. And 42 squared is 1,764 plus x squared. Now, same thing that we did down here, we need to get rid of this and it's positive, so we're going to have to subtract 1,764, subtract 1,764 here. Now those will cancel out and it'll give us x squared over there. And over here we have 5,625 minus 1,764. And that gives us 3,861. 3,861. That's x squared. So we still need to find out what x is. To undo squared, we take the square root. So we need to take the square root here. Now the square root and the squared cancel out and give us x there. And the square root of 3,861 is about 62.14. Now these don't come out even. You'll see on the calculator, they don't come out exactly even, but you're going to round to 2 decimal places. So that is how you're going to do the problems on your homework this week. So the next 2 pages in your packet are just the explanation of what we've just done there. And then let's look at the next page that has, it says, are they right? So this gives you 3 sides of a triangle, and you're going to test like we did here. You're going to test to see if it comes out to be a true statement. So this one has the sides 3, 4, and 5, which we know from our example that we just did. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25, and the other side, 5 squared, is 25. So that comes out to be a true statement. So yes, that one is a right triangle. So that's what you're going to do on all of these problems. You're going to test the Pythagorean theorem and see if it works. If it comes out to be true, then it is a right triangle. If it comes out to be false, it is not a right triangle. Now these, you're finding the missing side. So that's just like this one that we just did. This one has the longest side is 17, so that's the hypotenuse. One of the legs is 8, you're finding the other leg. So both of these examples are doing that, finding the other leg. You see the work there, they have it done, and you end up with the other side is 15. This one, number 2, also 61 is the longest side. It's across from the right angle. So that's the one that's by itself. 61 squared equals 60 squared plus x squared, and then you'll work that one out. Now, number 3 is different because this one, this looks like it's the right angle. So the hypotenuse is what's missing. So you're going to do 6 squared plus 8 squared equals the hypotenuse squared. And the same with number 4. These two are the legs. So 5 squared plus 12 squared will give you the hypotenuse squared. On number 5, it's back like number 1 and 2. You're given the hypotenuse is 30. So that one's by itself. Squared equals 18 squared plus x squared. And also on 16, you're given the hypotenuse is 20. So you're going to square that, have that on one side by itself, and equals 16 squared plus x squared. So just to practice with those. And then your last page is just a mix of things. So the first 3 are testing to see if they are right triangles. So it gives you all 3 sides. You're testing the Pythagorean theorem. We've done the first one here for you, and it did not come out to be a true statement. So this one is not a right triangle. So you'll test those other ones. And then the next ones are like the ones you were just doing. You're going to find the missing side using the Pythagorean theorem. And then 7 through 9, you're also finding the missing side, but note that C is the hypotenuse. This is always the longest side. So this A is going to be shorter. It'll be smaller than that. So A squared plus B squared equals C squared. A squared plus B squared equals C squared. And this one, the C is what's missing. So you just square this one and square that one, add them together, and you get that one. And at the last 3, it says find the number that would make the length of the hypotenuse a right triangle. So these 2 are legs. So you'll just square each of these and add them together, and you get the hypotenuse squared. So then you'll take the square root of that for those. And that is all.